Hello everyone, Miss.Marr here. This video will be part 2 for mapping, which is all about topography. Topography is going to be broken up in class into 2 classes. However, this video is just going to lump it all together so that way you can have all the information at once. So if you missed part 1, or day 1 I should say, or day 2, then you might see some repeating information, but that's good because the more you hear it, the better. All right, so here's some bell ringer questions for you. I want you to think about what the answer might be. If you don't know it off the top of your head right now, that's completely fine because that's the purpose of this lesson, is to try to give you this information so that way you're able to answer them. So here are the questions. Which way is Cinder River flowing? What is the elevation of point A? What does the profile of the line CB look like? And what is the contour interval? If you're not sure what some of that means or how to answer some of those questions, again, it's okay because I'm going to teach you that. I do want you at the end of this video to try to go back to this point in order to look at this picture and try to identify if you can answer these questions. If you forget though, the practice that we have in class will have the same picture in here, so you should be able to see this again and try those questions again. So again, today's lesson is all about topography, which sometimes you'll hear as topographic map. So those two words are the same, they're just kind of pronounced a little bit differently. So what topography is the shape of the land and its changing elevation. On a map, though, it displays the changing elevation. So each line that you see on this map is going to be change in elevation, and it's going to increase at a steady rate, which we'll talk about in a second. So here's one map. You'll actually, if you go hiking a lot, whether it's at Shenandoah Park or Shenandoah Park, you will see topographic lines or topographic maps on top of hiking maps. So oftentimes those trails and the hiking maps and the topographic maps are overlaid, and you'll see the trail markers. And this is great because the point of that is to show you, okay, which hike is going to be, really rough, which one is going to have a really steep slope to it. Maybe that's for advanced hikers, versus which trail has more of a shallow slope to it. That might be better to go on with grandma. Unless your grandma is, really spunky. I don't know. But you'll often see a picture like this on a hiking map, and what those lines are topographic maps. So hopefully when you guys go on vacation or something, you'll remember this lesson in this class. However, it can be kind of hard to visualize what topographic maps are supposed to show because it is 2D. And sometimes if you have a more advanced eye like I do, because I studied this and I teach this, I can see what this is supposed to look like from a 3D point of view. But that's a hard skill to develop. So I'm going to try to throw in some pictures on the majority of the slides so that way you can see the topographic map and what it looks like. So here is a separate image, and on the bottom is our topographic map. You can see all those lines on here that represent different values of elevation, but if you notice, they all steadily increase by the same amount, which here would be 10. We go from our 10 line to our 20 to our 30 and so on. So there is a steady increase, which is helpful because it allows you to be able to interpret what the following lines should be equal to if there is that steady increase. Again, it might be a little bit hard to figure out what this looks like though on a 2D scale. So even though I can see the 3D rendering above, what I see when I look at this bottom image is I see two groups, I'm holding 4. I see two groups of circles. I see one group of circles to the right, and I see one group of circles to the left. Every time you see a group of circles, what you're actually seeing is an increase in elevation to either a mound like a hill or a mountain. So I actually have, I went to Home Goods and I bought a baby toy because it's perfect, right? Here you have a whole bunch of little lines that you see where the outermost line is the biggest, has the biggest area covered, and the innermost line has the smallest area covered. if I take out these stars and I stack them, hang on, I have to do this slightly off screen. If I take these stars out of their box and I stack them, now you can see a mountain with the widest base, so the widest circle, the widest base. And as we get taller and taller, that area, that line, that, well, in this case, it's a star. See the star? We'll call it a circle though for topography. That tallest area of the mountain is the narrowest. It has the smallest circle or smallest star. The base has the widest circle star here, right? Base is widest, top is smallest. So again, if I were to put them back in their organizer, this is a little tricky. Hang on. If I were to put them back, they all nestle together perfectly with the widest one on the outside, or the base on the outside, and the very smallest, the top of the mountain, right on that interior. Every time you see a group of circles on a map, on a topographic map, you are seeing an increase in elevation, just like you saw here, which, so I don't have to stack it again. Here's the matching toy it came with, right? So widest at the base, largest circle at the base. As you go closer and closer to the top, you're going to get a smaller circle and a whole bunch of, I know these are stars, but you'll get smaller and smaller and smaller circles as you go closer to the top, and vice versa as you go closer to the base. So hopefully you're able to see that now. Again, here I see two groups of circles, a left and a right. When I look at the 3D rendering above, I see two mountains or two hills in this picture. So finding those is quite helpful because that really does help you look. Going back again to this picture of the hiking map here, right, by Abrigo, I don't know how you're supposed to say that, we see a whole bunch of circles that are nestled together, getting smaller and smaller and smaller until this X point. So what we're seeing is a mountain, and that X is the peak of the mountain. So hopefully you're able to kind of like start seeing it a little bit more. So again, going back to those lines, every single line, I shouldn't say every single, the majority of the lines that you see on the map are contour lines. I say majority because sometimes you can have hiking trails and sometimes you can have rivers and roads. I'm pretty sure this white outlined line is supposed to be a road, but they'll be labeled, like this trail is labeled, this trail is labeled. This river is colored in blue, so you can tell it's a river. But the lines on a topographic map should be, in general, contour lines. So these are lines that display elevation. Now, because they display elevation, they are not going to ever touch. If they did touch, if they cross like this, what you're saying is, even though there's two separate contour lines that represent different values, one might represent 10 feet of elevation, another one 20 feet of elevation. If they cross, you're saying at that location where they cross, we have an elevation of 20 and 10, and that's not possible. You can't have a piece of land that's worth both. And if you find one, let me know. But as far as I'm aware, you can't. If you had an elevation of 30, that's fine, but you would use a 30 contour line. So you would have another contour line. So each contour line does increase by a steady value, which we'll get to in just a second. Now, some of these lines are bolded that we see here. These are what we call index contours. So index contours help us to kind of not brace ourselves, but kind of establish our footing. Where are we? What are some values here? And it helps us determine what that steady value is. So these are the index contours. These are the ones that are going to be bolded, and these are also going to be the ones that are labeled. So here I have one index contour. It still is a contour line, but it's kind of like the leader in the group, right? And then, so that one's worth 9,000. I think this is feet, not meters. And then a little bit later, we have 9,250. and then we have 9,500, and then 9,750, and so on. Those are our index contours, but there are a whole bunch of other lines between them. The reason why we don't label every single line is it would get messy. So instead of labeling every single line, we generally label every fifth line because we can easily count the lines in between. Remember that all the lines increase by a steady value. That is called our contour interval. So that steady value, that contour interval, is what we are counting by. It's not the value of each line, because remember, the value of each line changes. I might have a 10-foot line, and then I might have another line that's equal to 20 feet, and then another worth 30, 40, and then 50, and so on. So each line has its own value, and wherever that line touches represents land that has that exact elevation. If it's not touching that point, if land is not touching that line, then that land is not equal, or its elevation does not equal that of the contour lines. If that land is touching the line, then they do have the same elevation. But if it's off of it, it's not equal to it. What is it equal to? It's equal whatever is between the two contour lines next to it. So it's got to have an elevation greater than the contour line below and less than the contour line above. It cannot be equal to them. Anyways, going back to contour interval, kind of got a little sidetracked. This again is what you're counting by. So the example that I used, 10 feet, 20 feet, 30 feet, 40 feet. What am I counting by? I'm counting by tens. That is my contour interval. Here, for example, I use my index contours for simply the purpose of figuring out what my contour interval is. So here, my index contour says I have an elevation of 9,000 feet. Every single piece of land touching this line is equal to 9,000 square feet. The land over here, right? It's slightly under that line, not equal to 9,000, right? It's worth something less than 9,000. Anyways, so we have our index contour, 9,000. Then we have our next index contour, 9,250. So I have to figure out what our contour interval is, and I'm going to do that by trying to figure out what these lines are counting by. All right, so I know that these are about 5 apart. Here's line 1, 2, 3, 4, and then include the next contour line in your fifth, or in your counting, 5. Just like how you do, if you're counting to 50 by tens, 10, 20, 30, 40, 50, right? You include the last one. So I'm going to guess, just because I've done this a lot, that I'm counting by 50. 9,000 and check, right? 9,000, 9,050, 9,100, 9,150, 9,200, 9,250. So I'm counting by 50s, and I used my index contours to figure that out. That's pretty much the main reason why we bold them, is that way we don't have to label and we can figure out what we're counting by. We don't have to label each one, sorry, and we can figure out what we're counting by for the minor lines in there. All right, so I'm trying to think what else I still need to cover with this one. Yeah, main thing with contour lines, they don't touch. Each one represents its own value. If a location is touching that line, it has the same elevation as that line because it's on it. If a location is not on that line, if it's a little bit off, then its value is somewhere in between the two contour lines. It's in between. So if it's in between 9,000 and 9,050, it has some value between the two. With those locations that are found between contour lines, you're never really going to get an exact number. They're just, if you get a question on this, they're really just looking to see if you can identify some number in the range. So again, if my dot were here, my location were here, it's above the 9,000 line, but below this next contour line, which we know since we're counting by 50s, is 9,050. So I might guess that this elevation is 9,040, and I would be correct. If my neighbor guessed that it was 9,030, they would also be correct. There's, again, no like precise, correct, specific one number. It's really just any number between those two contour lines. But again, it's not equal to the contour line unless it's actually touching it. So hopefully that's like going through. It's not equal to the contour line unless it's touching it. And its value is whatever is greater than and less than the two values of the contour lines on either side. I think I butched up that last part. But let me know if you have any questions. All right. Some other things that you might see on contour maps are things called depression contours. This is trying to display areas on a map that specifically are sinking in, not necessarily a downhill slope, because you can just simply show that, for example, going back to this picture, you can simply show that by, how do I express this? On a mountain, you can climb up a mountain, and you can also climb down a mountain. So I could read up the values, and I can also read down the values. But what if at the top of this mountain, it doesn't reach a peak, it actually maybe caves in, right? How would I show that? That's when the depression contours would come into play. So this really shows a depression surrounded by rising elevation, because otherwise you could just show a slope down, but this doesn't slope down. It, from all sides, caves in. So to show a cave in, we use tick marks. And you're really only going to see these in circle formations because, again, that's our cave in that we're seeing, our depression. Something to note about the tick marks, they go down by that same interval. So for counting by tens, they're going to go down by tens as well. Each contour line with a depression tick mark goes down by 10, but the first line with the tick mark is actually the same value as the last line without a tick mark. So these two are going to be the same values. It's basically saying, hey, stop counting. Okay, here we go. We're going to start counting downward now. And then the second contour line and so on are the values that are now decreasing by whatever your interval is. The area in between is some value that is greater than your last contour line without tick marks, but also less than the value of what could be the next contour line if there were another contour line. And I'm not talking about contour line with a tick mark. For example, it looks like we're counting by 200s here. So this value between the last tick mark or the last contour line without tick marks and the one with tick marks can be as great as 1,399, not 1,400. 1,400 would be the next contour line, but it's not there. The last contour line is 1,200. So any location in the middle right here would again have some number in between. So not 12,000, not 1,200, but 1,201 all the way until 1,399, not 1,400. The reason why, again, that contour line is not present, so it has to be something less than that contour line if it were there, but something greater than the current contour line that is there. So hopefully that helps a little bit. What else? So some examples of where this is relevant. Mountains with some kind of a dip at the top. Usually it's because it is a volcano and the volcano system itself started to collapse in on itself, creating that depression. Craters are also a really great example. Sometimes you can even see lakes that all the water's been removed, but that's its own separate thing. I would really just think about craters from like meteors or volcanic craters as well, which are at the top of mountains. That's when we mainly use depression contours. Next thing that you might see on a topographic map are rivers. So they want you to be able to identify where a river is flowing. And from a survival standpoint, this is very important, right? You have your map, you're hiking, where's the river flowing? That's going to tell you how to get downhill. I mean, you could also just follow downhill, but sometimes that doesn't always work because maybe you have a whole bunch of up and downs and up and downs. Anyways, so one of the popular questions on tests is, which way is the river flowing? There's a few different ways to figure this out. I do want you to remember all three because sometimes one method might not work. Sometimes another method might not work. So if you have knowledge of all three, you're secured. You'll always be able to figure out where the river is flowing. So one way, water flows downhill. So if you have elevation marker, if you have contour lines and you can see, okay, well, this one's starting at, or the river is going through the 400 line and the 300 line. Well, I know that my river is flowing from the 400 to the 300 because water flows downhill. That's one method, but I've actually seen questions where contour lines are not labeled or index contours are not labeled, so you can't really figure out what the elevation is, and so therefore you don't know if it's going up or down. One second. Another method is to look for the ocean because all water eventually dumps out into the ocean. The ocean, if we're looking at a topographic map, is 0 feet. It is sea level. So all of our water will eventually flow to that 0 feet, to that sea level. However, I do and I don't like this one because what I see is sometimes students don't remember it's just the ocean and they'll see a lake on there and they think, oh, okay, well, it's going into water, so it must be going into the lake. And that's not always the case. Sometimes, sure, but not always. A lot of times rivers, or not rivers, lakes are actually the headwaters of rivers. So they're the source of the rivers and they flow down from it. For example, where my husband's from in upstate New York, the headwater for the Shenandoah, for the Susquehanna River is Otsego Lake. And that flows all the way from upstate New York to the Chesapeake Bay, where it eventually dumps out into the Atlantic Ocean. So Otsego Lake is a lake, but the water's not flowing into it. It's flowing into the Chesapeake Bay, which eventually dumps out into the ocean. So it's important to know it's only oceans. If you see a lake, it's not a guarantee that the water is flowing into it. So that's kind of like my gripe with that one. And then the last one is that if you're looking at the contour lines tend to bow around the river because that river is cutting into the landscape. So you will see kind of that like that erosion in the form of V's forming through the contour lines. So again, the contour lines are going to form V's like you see here in this bottom picture. And if you can remember that the water flows out of the V, then you'll be able to identify the direction that the river is flowing. So I like to think V as in valley, waters flow out of valleys, right? Think about our Grand Canyon is kind of like that valley and the water's flowing out of it. So here we have those V contour lines that are forming. The river flows out of it. But you can also see it's also flowing towards the ocean. And you can also see elevation-wise. Here's 100 feet. Here is 0 because it's right at the water. And I know it's flowing downhill. So there's a few different methods. I would try to remember multiple because you don't want on a test to be stuck with just one method and then that method not work because you're not given enough information. So try to remember all three of them, preferably. All right. That should be where we ended for part 1 of this lesson. And this will be part 2. I'm fairly certain. Yeah, I have a feeling that's probably what we'll do. Anyways, the next part, so for day 2, we're going to look primarily at slope. This is where a lot of the questions come in. The previous one, it's all about finding elevation, determining the direction of water flow, understanding how tick marks work for depression contours, what elevation might look like, elevation change might look like. But this one is really where a lot of the technical skills come into play. So the first thing that we're going to look at is slope. You can actually determine the slope in a few different ways through topographic maps. The first one is not using calculations at all, but you're also not looking for a calculated number. You're just looking for steepness in terms of greater than or less than. So if you look at contour lines, wherever they are smushed together the most, that is the steepest part of the map because each line represents a change in elevation and a steady change in elevation. So if all of those lines are close together, you have a lot of change over a short period, or rather a short distance. If the lines are further apart, especially the same number of lines are far apart, you're going to have that same amount of change in elevation, but over a greater distance. So that slope is going to be a lot shallower. So when those lines are close together, just like you see here on the right-hand side, we have a very steep slope. When the lines are further apart, over that larger distance, you have a much more shallow or gentle slope. So that's something to look out for on maps is the closeness of those lines. I hit everything here. Yeah. Something that they might ask you to do as well is to calculate the gradient. In math class, you have to calculate the slope of whatever it is that you're doing, and you're actually going to use the same formula here. So if you ever ask your teacher, when am I going to use this? Earth science, that's when. So what we're looking at is a change in x over a change in y. Your change in elevation over your change in distance. It's a little bit simpler though when you go to look at it. So I'll show you how to do it. So gradient is slope. It's the change in slope over that distance. To calculate the gradient, you're going to divide, or you're going to find rather, your change of value of your elevation. So how elevation changes from whatever point to whatever point, and then you'll divide it over that distance. How are you going to determine what distance is? You're going to use the map scale on the very bottom, but it actually involves a physical piece of paper, which I will grab. Let me grab a sticky note. So first off, with this map, we have to figure out what x and y are equal to, right? X, well, we'll start with y. Y is actually right on our index contour line. It's the bolded line that's labeled, and it has a value of 300. Now, my contour interval is not labeled here, so I have to figure it out on my own. Sometimes it is listed and it'll be so somewhere on the map or in the legend, but it's not, so I have to figure it out. I have one index contour line labeled at 300, and if I count the lines 1, 2, 3, 4, plus the last one, 5, my fifth line is equal to 400. So 400, 300, what am I counting by? I'm counting by 20. The difference there, 400 minus 300 is 100. 100 divided by 5 is 20. You can also guesstimate too. Maybe you thought it was 10. We'll count up from there. 300, 310, 320, 340, 300. Did I say? I think I skipped 30, 40, 350. That doesn't work. So now I'll try 320 or 20. And if you count by 20s, you get to there. So I know that I'm counting by 20s, which is great because I already know what y is, but x is not on an index contour line, so it's not labeled. So I have to figure out what it is. It's on the line 1 less than 400, so that would be 380. So x is equal to 380, y is equal to 300. Okay, what's my change in elevation? 380 minus 300, 80. That's my change in elevation. But I still have to divide it by my distance. So what I do is I'm going to take a piece of paper like a sticky note, and on my paper, wherever I'm doing my practice problems or my test, I am going to take my piece of paper and I'm going to bring it to my map scale. So here yeah, I have the same picture. Okay, I have my map scale. I'm going to, hang on, let me do this. Actually, I'm going to put my sticky note on my line, my X and my Y line, instead of my scale. All right. I'm going to make a mark on my sticky note. Sorry if my hands are shaking. I'm going to make a mark on my sticky note that says X and Y, so I can see that this is the distance between X and Y. Then I'm going to remove it and place it on my map scale. Let me stick that so it's a little bit cleaner. And this worked out perfectly. The distance between X and Y is equal to 2 kilometers. So that's, I don't know if you guys can see that. I'm not looking at my screen. All right. So that's how you would determine distance. So my distance between X and Y is 2 kilometers. My change in elevation is 80. Is it 80 feet? I don't see if it's doing feet or meters or anything. Anyways, so what is 80 feet divided by 2 kilometers? 80 divided by 2 is 40 feet. So if you needed me to write that out on a sticky note, what I did, X is equal to 380. Y is equal to 300. So what I need is 380 minus 300, which is 80. Boom. Actually, I could probably do that down here. Boop, 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 boop. 80. And then I need 80, which is my elevation. I'm just going to abbreviate it, elev, divided by my distance, which is 2. Distance. And that equals 40 feet per kilometer. All right, here's my kind of messy sticky note. Okay, X is equal to 380, Y is equal to 300. Subtract the two values to get your change in elevation, which is 80. Change in elevation divided by distance, I determined that to be 2. 80 divided by 2 is 40 feet per kilometers. Hopefully that helps. That's a pretty popular question. That's specifically how to determine gradient. All right. Sometimes, actually a lot of times, they'll give you a question and they'll ask you to identify what the peak is, what the peak elevation is on a mountain. We've kind of already talked about this, right? If we have land that is not on a line, it's not going to be equal to that line's value. So the summit, which is the same thing as the peak, is above this 350 contour line. So I know that the peak of this mountain is going to be higher than 350, but how much higher? Well, because there's no other contour line, it has to be less than what that contour line would be equal to. So I have to figure out what the next one would be equal to. This map is nice because every single contour line is labeled just in a slightly different part. So if you're ever confused, like, I feel like there should be a label, look all around that circle because it might be present. So 350 is the last contour line before the summit, before the peak. The one below that is 300. So it seems that I'm counting by 50. So if that's the case, then the summit can't be any higher than what another contour line would be equal to because it's not there. So the highest that I could go is 399 feet. I can't go to 400 because 400 would deem another contour line. It's not there. So the highest one that I can go is 399. So the peak of this mountain is anywhere between 351 feet to 399 feet. It can't have the same value as a contour line since it's not on that contour line. Same thing with this little triangle here. It actually is labeled though. They sometimes will label what the peaks are equal to. In this case, it's 325. So just a note, that's another popular question, is determining what the peak elevation is, which sometimes is called summit or apex. That's another one too, which is a game. My husband plays that one with his sister. Okay, here's another. Do you guys need to pause? I need to pause. This is a long video. I'm trying to do this during my planning before all the bells ring. Fun fact, I made this on a different day and got interrupted like 4 times. I just deleted the whole video. I'm starting over. So another really popular technique that you should try to master for this unit is all about profiles. So a profile is a side view of the mountain, especially since we're looking from the top. Like all of these topographic maps are aerial views. Aerial, like you can see them from the air. Think like bird's eye view. We have to try to figure out what they look like as if we were standing facing that mountain. What would it look like from the side? There's a few different ways to determine that. And before I even begin, when we're talking about profiles, we're specifically talking about from point whatever to point whatever. Because I can look at this and I might get a little overwhelmed. But when we're talking about profiles, we're specifically talking about from, for example, point A to point F. How does the elevation change along that line? So again, there's a few things that you're going to do. You're going to look for the spaces between lines. Just as we mentioned before, the spacing between lines is going to determine how steep or gentle a slope is. So that's going to be key. We're also going to, of course, look for the values of our contour lines because that'll tell us how tall to how, or not tall, but how, tall, how high the highest point is, how low the lowest point is. So we're definitely going to look at our values. Rivers too are great. Rivers should generally be around the lowest, but they also do flow towards the bottom too. So you want to look out for rivers. Generally speaking, though, they'll always be in those valley type areas. And lastly, you want to look for those groups of circles that we mentioned at the beginning of this video, all the way back, 20 years ago, because it feels like forever. All those groups of circles are going to represent your mountains. All right, they're going to represent your mountains. So if you have one group of circles, one mountain. If you have two groups of circles, you'll have two mountains, and so on and so forth. So that'll help you kind of figure it out. Let me move this for a second. But here's a popular question again. So what does points A through F look like? This is personally how I would go about, oops, hang on, I gotta go back. This is how I would personally go about doing it. What am I starting at? A to F, what are those elevation points? All right, well, here I have 100. And that is the only line labeled on here. I do have a 100 on this side, and I do also have a 100 on the other side. By the way, you can have multiple contour lines with the same value, but generally that really only happens if they're celebrated, if they're separated by a low point, right? And they increase in elevation on either side. That's really the only time that you'll have multiple. But again, 100 is the only labeled line. I don't have a contour interval listed. However, actually, this is a lake, so that's not the best example. But pretend we're the ocean. That would be 0 feet. So 0, I'm assuming 20, 0, 20, 40, 60, 80, 100. I'm counting by 20s here. So 100 is this first index line. I go up 120. I go up to the line that has A on it, 140. A should be around 140. That's what we're starting at. Let's see what I can. Am I not counting by 20s? Because this has. Okay, so let's say that this is 50 feet because it looks like I'm counting by 10s instead. All right. Fine, we're counting by 10s. So I guess this lake is 50 feet above sea level. Then we'd go 60, 70, 80, 90, 100. I guess that's what they want you to do. I wish they labeled something else though, but whatever. So 100, 110, 120. The reason why I knew something was off is because the highest value for each option was 120, except for this one, which we'll talk about in just a second. So there's no 140 as the highest, which is why I knew, oh my gosh, and it says contour interval right here. It's been a long day. Anyways, so it tells you what the contour interval is. All right. Well, if A is 120, I can cancel out C because C doesn't start at 120 for A. So I can already cancel out an option. F is, here's 100. Now here's the tricky point. Am I going down in elevation or am I going up in elevation? Remember the circles. Remember the circles. As you go, if you have a nesting group of circles and you get closer and closer to the interior of that circle, so the smallest circle is the interior most one, that is actually highest elevation. So whenever you see that group of circles, the smallest circles, which is the interior most one, is the highest elevation. So since I'm going towards that smallest circle, I'm going up the mountain. So 100, 110. Okay, F hasn't quite reached 110. So it's somewhere in between 100 and 110. Could be 101 to 109. All right, well, I'm going to say that it's not B because B has F at basically 150. So it's not C, it's not B. I'm probably not going to say I don't know. It might actually. Oh yeah, and A is bolded, so duh. It looks like F is ending a little bit too low over here, maybe at like 90 feet, while this one is ending just under 120. So I guess that makes sense to be around that less than 110 but greater than 100 area. Let's look at some other things. We have two mountains. We're going from one mountain, so we're going downhill, downhill, downhill. We see a stream. We go uphill, uphill, up here, uphill. We hit the tallest part of the mountain because we're going through that center group of circles, and then we're going back downhill, downhill, downhill. So I should go downhill, hit the river, go uphill, and then downhill again. All right, which both of them kind of do. Downhill, 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 up again. This one has a few different ones though. But again, just looking at what F's elevation is, it looks a little too low. So I'm going to go with A. It is bolded though, but that's how you would do something along those lines. It's going to take a little bit to figure this out. You want to try to identify what your starting and ending elevations are. You want to try to identify the general trend. Are we increasing? Are we decreasing? Are we doing a bit of both? And also location too. Are we is the valley point all the way on the left, all the way on the right, in the middle? Like, what's the symmetry there? So there's a few different things that you need to keep in mind for profiles. Okay, so here's another activity, matching profiles. So now that you kind of have this thing down or under your belt, you should be able to try to match each one. It might be a lot to look at, but if you take each one by one, it's not so bad. So, and you don't even have to start at the top. You can start at the most obvious one. Pick one that's the most obvious. For me, I like to start with the second one because it has one circle, right? One group of circles, rather. One grouping of circles, all going to one centermost point, and it's right in the middle. That the mountain itself, the peak of the mountain, should be right in the middle. Well, it can't be this first one, can't be the second one, because technically there's two mountains, and the peak of the one mountain is off to the side. Can't be this one. There is one mountain, but it's off to the left. Can't be this one. There's two. It can be this fifth one, because one mountain right in the center, and it can't be the last one because it's off-centered. So I've now matched this second image on the left to the fifth image on the right. And you can keep doing that and doing that and doing that. Look for, this is my tip, look for centermost circles, look for those groups of circles. That'll tell you how many mountains you're working with. Look for where they're aligned. Are they aligned more left, more right, center? And then also look for elevation. For example, let's imagine, right, there's no interval, but let's imagine that we're counting by tens and that the first circle is equal to sea level, which is 0. All right. This first mountain on the left-hand side is equal to 10, 20, 30 feet, or rather somewhere a little bit less than 40 because we don't have another contour line. So we have, we'll just say 30 because it's the last contour line. We have a value of about 30 on the left-hand side, but on the right-hand side, we have a value of 10, 20, 30, 40, 50, 60. So the mountain on the right is double the size the mountain on the left. Which one could it be? Can't be this first one because they're about the same size. Could be the second one because those are two different sizes with the highest mountain on the right. Can't be the third one because we only have one mountain. Can't be the fourth one because we have two, but they're of equal value. Can't be the fifth because we've used it and there's only one mountain, and it can't be the sixth. So I've identified the first image on the left to go with the second image on the right. So that's how you would do something like that. And again, you can keep practicing with these. These two, by the way, the first image on the right and the fourth image on the right, look very similar, but notice the valley is much steeper with this one than this one. So something to look out for when you're trying to match them all together. By the way, you do have something like this in your packet. So after you've watched this video, if you've gotten this far, sorry, and you've done the practice, I will check it to see and make sure with anything in this packet, I will check it to make sure that you fully understand the topographic things, and whatever you're missing, we will work on. All right. The very last slide, we've made it. The very last slide is about creating your own topographic map, which is very similar to trying to imagine what the topographic map looks like. What you're going to do with this one is, and I actually kind of forgot a little bit of a line. You're really only looking at, again, that one line, the line between the 2 points that you're looking at, point A to point B or whatever. Here I've identified it in red. Generally, that line will be in the middle. If it's not in the middle, it should be listed somewhere. It should be drawn on there somewhere. But generally, they're asking for middle of the mountain, what is its profile? All right. What you're going to do if you are drawing your profile is you're going to draw a line from each one of your contour lines down onto your map. I would, as you're doing this on paper, lightly trace it. So I know that you're watching this right now, but you are going to do this in class, and I'll do this with you to make sure that you get it. But I would lightly trace a vertical, straight as possible line down to the graph on the bottom. The graph on the bottom will be blank, by the way, and then you will, like no drawings like you see here, and then you'll make the drawing. So draw a vertical line down, and then after you've identified what each one of the values are for the contour lines, you're going to place a dot at that value where that vertical line meets the value on the bottom of that contour line. So again, like this one has a value of 300. When I draw that vertical line down, I'm going to place a dot or stop my line where it intersects the 300 graph line. This second contour line is worth 320. I'm going to draw a line down until I place a dot where the 320 line meets the 320 graph line, and so on and so on and so on. Finally, you're going to connect all the lines with a dot. And that should help you, but not like a staircase dot, because that's not too natural in nature. So I mean, some places it does happen, but we're looking for kind of a smooth line that connects all the lines together, like you see here. All right. By the way, when you come to the tallest point, make sure you don't have to make a flat top. Make sure to kind of mound it a little bit. But if there was an additional line up here for 420, make sure it wouldn't go past 420 because there's no 420 line on this map. All right. Just to kind of clean up this lesson, I think this is about 60 minutes at this point. It might even be 50. Who knows? What I want you to be able to do for the test, I want you to determine the index contour. So where is the index contour? It's the bolded one. I want you to determine elevation. Okay, I give you points A through F. Are you able to identify what the elevation is of each and every one? I want you to, oh, and by the way, I want you to identify, I think I meant this for index, the contour interval. What are we counting by? It might not tell you on the map. So if it doesn't tell you on the map, how are you going to identify it? Use those index contours. I want you to identify the direction a river is flowing. I want you to match topography to a side profile like we did before, those 12 images. I want you to know the difference in steep versus gradual topographic maps. So steepness, close lines, gradual, far apart lines. I want you to be able to draw a profile. You're actually going to need to do this for a project that we're going to do. So be able to draw a profile like you see here. I want you to determine the number of mountains. So how many nesting groups of circles do we have? I want you to evaluate where the best place to build something would be. Look for flat land. Look for a lot of relief between your lines. Look for a lot of space between your lines. That's a lot more shallow, more gentle. You generally don't want to build on something steep. Sometimes, but not always. Want you to figure out which trail would be best for grandma, or which trail would be best for someone practicing for their decathon. I don't know, whatever. I want you to hang on. I want you to know that tick marks show a drop in elevation when they're surrounded by like increasing elevation. So again, that crater at the top of mountains or something. All right. Those are the main points that I have written. I have practice problems for you. I'm going to stop this video here. Please let me know if you have any questions, and I'll see you in class.